everyone, welcome to week 6. Here is a list of things that you will need before you get started watching this lecture. Before we start talking about material, I just want to talk about quiz number 5 real quick. Quiz number 5 is different than all of the quizzes you've seen so far. It's basically kind of a field study quiz. I'm looking for you to find 5 different organic compounds that you come in contact with either in your home, like in your shampoo, or in the foods that you eat, or in your work. So these definitely can be drugs. It might be really interesting for you to pick out drugs to use for this exercise, just so you can get a feel for their molecules and their molecular nature and how their structure is set up. But they don't have to be drugs. They can be something from your home. And so you just need to find 5 different organic compounds, find the structure of them using Google, or if you happen to have a lot of medications come in the box with a pamphlet, and it's written on that real thin Bible paper, and there's a section that's for the patient and a section for the pharmacist. Usually on the section that's for the pharmacist, the drug manufacturer will actually draw out the full structure of the active ingredient in the medication, so you could find it from there. If you do use that, you might want to just, before you scan it, tape down that piece of that compound, or you'll have to recopy it. Basically, it's just for you to find functional groups within real compounds that you have tactile experience with. This is really different than the rest of the quizzes or homeworks. So if you do have any questions about this, please let me know right away. This is due on Friday, and if for some reason you need a few extra days or something, make sure you let me know really soon, okay? Alright, so lecture 6.1, we're going to be starting off with carboxylic acid. This is the general representation for the functional group in the carboxylic acid. Here, this R can be any carbon chain. And the meat of our functional group is this portion right here. Sometimes you'll note, if you're using a line angle formula, you'll see it written like this, where this is your carbon here. This group is called the carboxyl group. And compounds that contain this carboxyl group are known as carboxylic acids. The reason they're called carboxylic acids is because there's a part of the functional group that acts as an acid. Remember what an acid is? An acid is a proton donor, or an H+ donor. So this is the part of your functional group that acts like an acid. This H can be donated. That's making it an acid. Okay, so let's move on to nomenclature right away. You're going to firstly identify your longest carbon chain like we've been doing. And now you just have to make sure that your carbon chain contains the carboxylic acid at one end. Now, if you'll notice, going back to this slide here, this is always going to be the terminal of your compound. This is the end. There aren't going to be any other things after this. If it ends in an H, that means end. There aren't any carbons after this. That would be an ester, but we don't want to get ahead of ourselves. Okay, so identify your longest carbon chain. And step 2 is to number the chain so that your carboxylic acid carbon is carbon 1. So this is always, always, always going to be number 1. Step 3 is the same as it's been. Name, number, alphabetize your substituents. And then here's where things get a little bit different. Oh, there it is. Okay, if you have an acyclic carboxylic acid, in other words, a long chain and not in a ring, you're going to remove the E from the end of your parent name and add oic acid. So if you had hexane, hexane would turn into hexanoic acid. Oops. Hexanoic acid. If you have a cyclic carboxylic acid, what you need to do is name the ring like you normally would, and then add carboxylic acid as 2 new words. So here you would have something like cyclopentane carboxylic acid. There's a difference between naming these two types of carboxylic acids. So you're going to want to circle this, if you print out the lecture notes, go ahead and circle this part of the slide. If you don't print out the lecture notes and you write them down, make sure that you highlight this or make a note of this in your own notes. So here we have hexanoic acid and here we have cyclopentane carboxylic acid. Okay, let's do a few examples of this new type of nomenclature. Find your longest carbon chain and number. Okay, so we have 5, that would be pentane. We've got one substituent, we've got 3-methyl. So if we take off this E and add oic acid, we'll have 3-methyl pentanoic acid. 3-methyl pentanoic acid. The only thing that's tricky about naming these guys is that this thing right here is actually a carbon and that gets the number 1. Other than that, this is the same as what we've been doing for the last week. Okay, here's another example. One good thing about the carboxylic acids is that you always know where to start, because this is always carbon 1. So that's something that's a little bit easier. You don't have to worry about substituents getting the smallest numbers or anything, because this always has to be number 1. Okay, now there's something in here that's interesting that we haven't seen yet before, and that's a chlorine. Chlorine is in group 7A on your periodic table, and you might want to go ahead and find that on the table. It's the second to last column on the right-hand side. Chlorine and all of the other members of its group are called the halides, and they have a particular prevalence in organic compounds. So we need to know how to name those. Here's the list of the abbreviations for naming these as substituents. Fluorine is fluoro, chlorine is chloro, bromine is bromo, and iodine is iodo, although you won't really see iodine a whole lot in organic compounds. Okay, so we will use this chart to name halide substituents. For example, here, if we wanted to name this is just an alkane, and so here we would just name this as 2,3-dichloro-pentane. It follows all the same rules as the methyls and the ethyls. They just have different little abbreviations that you need to be aware of. So circle this for your naming for on your homework. And we'll go back to this example here. So here on the 3 group we have a 3-ethyl. And so far in all of our homework that ethyl is usually coming first, right? As far as your substituents go alphabetically. Well, now that we've got those halides, chlorine is usually going to be first. So here we have that 4-chloro. Now if we put all these things together in alphabetical order and name this as our carboxylic acid, we should get as our final answer 4-chloro, 3-ethyl, hexanoic, oh boy, got a little bit sloppy there, hexanoic acid. 4-chloro, 3-ethyl, hexanoic acid. And now just to note that these are 2 separate words here now. Acid is a separate word on its own, but still part of the name. Okay. Let's do this cyclic compound as our example. So here we have to call this carbon 1. So then we can number in either direction, it doesn't matter. I'm going to go clockwise at this point because either way, those two methyls are going to be 2 and 6. Okay, so let's do that 2,6-dimethyl part. That should be really easy for you guys by now. And now we just remember, name that ring the way we would name it if it was just a plain alkane. So that'd be cyclohexane. And now, do you remember what you're supposed to add at the end? Carboxylic acid. 2,6-dimethyl cyclohexane carboxylic acid. Here's another one of those. Now here you have to number counterclockwise so that this ethyl has the smallest number, because ethyl comes before methyl in the alphabet. So here we will have 2-ethyl, 5-methyl. This is a cyclopentane, carboxylic acid. That's a lot of writing there. Okay, here's another one with some bromines on it. Now, I'm not sure if you guys are doing this because I haven't graded your homework yet. But if you have to write out the numbers in your chains, there's no shame in doing this. And when I post my key for homework 5, you'll notice that sometimes I even have to write out all my numbers. There's no shame in having to do that. If it keeps you from screwing up numbering, go ahead and do it. Okay, so we have 2 bromos, 2,5-dibromo. We have 2 methyls, 4,6-dimethyl. This is a heptane, so that would be heptanoic acid. The longer the name, the better I like it. You don't normally get to write words that are that long. Okay, let's do a few from your homework. Here we have number 3 on page 1. Now, you should probably pause it and then check back to see if you get the right answer. And now, I did last week in my lecture neglect to tell you what the prefix was for 4. It's tetra. I'm really sorry about that. That was my omission. So here we have 5,5,6,6 tetramethyl, nonanoic acid. Nonanoic is how you say that. Okay, here we have number 5. So this would be 1-ethyl cyclopentane carboxylic acid. Make sure you watch your spelling because I will grade for spelling. If you spell something incorrectly, you'll lose points for that. 1-ethyl cyclopentane carboxylic acid. Okay, and now here's one where you have to draw the picture from the name. So let's try this out. Okay, always start from the back. Let's do pentanoic acid first. That means a chain of 5 carbons. 1, 2, 3, 4, 5. And then 3,3-dimethyl. Now, when you are drawing your compound, it's kind of bad form to number those carbons. So if you have to do this, that's fine. Either erase it, or just clean it up so that it looks like this. So you don't want to have bad form. And that's how you draw the compound from its name. Equally fun. Okay, there are 3 what are called common names. And these are the names that were given to these carboxylic acids before our whole systematic nomenclature method was devised. And these names have sort of stuck. So this compound here is the simplest carboxylic acid you'll see. There's only one carbon in the whole molecule. This one right here. This is its molecular formula. Here is its structural formula. That's what it looks like here. This is formic acid. Here we have acetic acid, aka vinegar. This is what acetic acid looks like. And this last one is called benzenoic acid because it has this benzene ring that is attached to the carboxylic acid functional group. So that's where we get that name from. You should memorize these, or at least keep these three things handy so that in case I refer to them in the future, especially this one, that you can come up with CH3COOH as the formula for acetic acid. I think, but I'm not sure that this might be on your pink sheet. Oh, the acetate anion might be on your pink sheet. The conjugate base of this acid. That confuses you. Go back to the acid-base lecture, or unit, I should say. Okay, now I just want to talk to you about a few interesting carboxylic acids that you'll see. You see this probably every day in your practice. Maybe you even take an aspirin every day, or you use it as a pain reliever. Acetylsalicylic acid is the name of aspirin, and it has the carboxylic acid functional group. In fact, this compound has three functional groups. This, and this. But as for right now, we're just worried about this part of it because that's what we're working on right now, the carboxylic acid. So this is aspirin, a carboxylic acid. And now I have a few pictures on my camera for you. One moment. Okay, a couple interesting ones from my textbook. This is butanoic acid. 4 carbons, that's where you get the butane, butanoic acid. Butanoic acid is what contributes to what your body odor smells like. So when you smell yourself, that's partly because of butanoic acid. It's produced by bacteria in your underarm region. This is hexanoic acid, or caproic acid is its common name, and it is what it's what gives you a like stinky feet smell. Then we have lactic acid, which is what is a byproduct of glucose metabolism. So when you're exercising a lot and you feel that burning in your muscles, that's a buildup of this compound, lactic acid. And one moment. I apologize for the crookedness. Here is aspirin, acetylsalicylic acid. Here is salicylic acid. Salicylic acid is commonly used in acne face washes. It's an astringent that dries out the oils on your skin, and that is a carboxylic acid, and that's the compound. In our next lecture, we'll be learning about esters.